This is problem number 6 on the practice problems for test number 3. Express the following power series in sigma notation and determine its radius of convergence. 3x minus 9x squared over 2 plus 27x cubed over 3 factorial minus 81x to the 4th over 4 factorial plus ... So first we need to write this in summation notation. So I'll put an equals here, summation. All right, the first thing I'm going to capture is the x to a power. So it feels like since you're getting all the powers, it's just going to be x to some generic n here. And then the next thing I'm going to do is capture the fact that it looks like whatever the power is, the factorial is happening downstairs. So a third power is a 3 factorial. Up here we've got a 4th power, and then down below is a 4 factorial. So then in general over here we have an n power. So then what do we put down below? We put an n factorial. And then the next thing to do is handle the number that's in the front. So let's see, I've got a 9, I've got a 27, I've got an 81. Every time we multiply by 3, but you really need to have an explicit way to get this as opposed to how do I build the one number from the previous number. So those guys right there, the 9, 27, and 81 are all powers of 3, and that's the key here. These are all 3 to a certain power. 9 is 3 squared, 27 is 3 cubed, 81 is 3 to the 4th, and lo and behold, that power is also matching the power on the x. So in general, it's an n. And then we just need to figure out what the starting value is here. So the first power that I see on the x is 1. So this n right here needs to start at 1. So I will put n equals 1, and then we'll just double check the first term. If n is equal to 1, then all of this stuff becomes 3 to the 1 times x to the 1 over 1 factorial, which is just 3x. So this is where we check that n equals 1 actually gives it to us, because that one looks a little different in terms of the pattern. Okay, so that's the series in sigma notation. I guess we'll put an infinity up here because it goes forever. And now we want the radius of convergence. So whenever we do one of these power series, the ratio test is always the right test. So let's use the ratio test. So we're going to let L equal the limit as n goes to infinity of one term divided by the previous, and then absolute value around the whole thing. Limit n goes to infinity. Okay, upstairs, the a sub n plus 1, focusing on this part right now, it's just all of this, but those n's all become n plus 1s. 3 to the n plus 1, x to the n plus 1, divided by n plus 1 factorial. And then it should be divided by a sub n, which is just a carbon copy of this, but just to save some space, we're going to immediately change this to multiply by the reciprocal. We'll put here times, and then we'll multiply by the reciprocal, n factorial over 3 to the n, x to the n. And that's still an absolute value, which is important here because there are x's, and we can't say whether those x's are positive or negative, so we need the absolute value. Okay, the next big piece of this problem is the simplifying. Limit n goes to infinity, that gets copied over and over again. So let's cancel these 3's. We have a bunch of 3's upstairs, one fewer 3 downstairs. So there's going to be a solitary 3 left over upstairs. Let's cancel the x's. So there's n plus 1 of them, there's n of them, there's now a solitary x upstairs. And then in terms of the factorials, I think we've seen this before, n factorial, n plus 1 factorial, we'll have a single n plus 1 left downstairs. And it's still an absolute value. And next thing to do is take that x outside. Okay, next thing to do is to take that x outside. As far as the limit is concerned, x is a constant. The variable for the limit is n. So this is x times the limit of 3 over n plus 1. No need for absolute value anymore. You can still put it, but everything here is positive now. But that limit when n goes to infinity is 0. So this is really absolute value of x times 0, which is just plain 0, which is one of our special cases. So this is the case where either the interval of convergence is just a single number, the center of convergence, the center of the series, or the interval of convergence is all real numbers, and we need to know which one is which. So the ratio test always wants you to set whatever you get to be less than 1. And this thing right here is always true, that 0 is less than 1. And it's true for any x, which means that the interval of convergence is all real numbers. You pick any x you want, and that series at the very top will converge. And that means that the radius of convergence is infinity.